Welcome to section 2.6, rational. We are going to begin today by doing a little kind of exploration in this video by looking at the function f of x is equal to 1 over x. And before we even get into that, a good little self-quiz is what's the domain of 1 over x? And the way, there's only one way that this fraction could be undefined. That fraction would be undefined if x was equal to 0. So you'd say this domain is all real numbers except 0. All right, so that's important to note as we're going to try to graph this. We won't be able to plot a point at 0. And in fact, I have a mini t-chart made up right here that we're going to, I would hope, if you're taking...
Coach Frederick, before you leave the building, please stop in the main office. Coach Frederick, before you leave the building, please stop in the main office.
I would hope if you're taking pre-calc, then filling in this t-chart shouldn't be too difficult. For example, 1 over 0.01 would be 100, or this would be 1,000. We already answered this one earlier talking about domain. This is undefined. What this is going to allow us to have is a pretty decent graph. Another coordinate that might be of interest, now I wouldn't put it necessarily on our graph, but if x was 100, then y would be 0.01. And if you don't like this, you could always rewrite this as 0.1 if you prefer to work with decimals. Okay, so if I go to plot this, well, 10 comma 0.1 is way out here. And let's see, 1, 1 right here. And let's see, 0.1. Those are really the only 3 points that I have that I can really plot. Now I know I know positive 0.01 comma 100 is going to be way, way, way up in that direction. And I also know 100 comma 0.01 is going to be way, way out in this direction. So what this graph looks like, it's got to pass through here, and it's very quickly got to flatten out. Right. This graph has what we call asymptotes. This graph has some asymptotes in it, and this is only half of the graph. The other portion of this graph that I'd like to look at.
The main office, J.B. Diaz to the main office, please.
Well, if I was to make x negative in all of these cases, how does that change your y values? Well, all your y values would now be negative. So instead of making a completely new t-chart, there's our completely new t-chart just by adding negative signs. So what's the second half of this graph going to look like? Well, it's going to have negative 10 comma negative 0.1. It's going to have negative 1, negative 1. And it's going to have negative 0.1 comma negative 10. So that final graph. So the key thing that you need to be asking yourself, what's going to happen to this graph at x equals 0, right where I'm drawing this dotted red line? What's happening at x equals 0? It's a vertical line right there. We call this a vertical asymptote right here. A vertical asymptote. This dotted red line right here. Right? A graph can never cross a vertical asymptote. As it approaches it, it either rises very quickly or falls very quickly. In this instance over here, as it approaches it from the left, it is falling very quickly, and then on the other side, it continues to fall as if you approach from the right towards the asymptote, you'd say it's going upwards. But what we also have is this dotted line I'm drawing here in blue. That's our horizontal asymptote. Horizontal asymptote. That's our horizontal asymptote. Again, a graph will never cross an asymptote. And especially for a horizontal asymptote, as x gets very big, that means very far to the right and very far to the left. The graph can never be crossed. Technically, you could cross a horizontal asymptote somewhere in the center of the graph, but we don't see that in this case.
Please report to the health room. Mr. McKee, to the health room, please. Thank you.
All right. So here's a couple notes in terms of rational functions. So a rational function is just a fancy way of saying x on the top and x on the bottom. So there's some function that represents the top. They chose n of x because it stands kind of for numerator. And there's some function on the bottom, something involving x. They chose d of x, think denominator, something that involves x in the denominator. All right. So asymptotes will appear. Asymptotes will appear in a few places. Vertical asymptotes. Well, if you go back to the very last slide, I'm going to jump around here a little bit. X equals 0 was not in the domain. X equals 0 was the equation of our vertical asymptote. That's not a coincidence. That's a guarantee. If a number is not in the domain, then it'll have a vertical asymptote. So if a graph has a 0, then that's going to be, the zeros of the denominator are areas that are going to have vertical asymptotes. And another way to think about this, while this, you're not going to find it written this way, values not in the domain, that's another way to think of it. Because if it makes the bottom 0, that's going to make the graph rise or fall very rapidly as it approaches a specific number. Okay. In terms of horizontal asymptotes, you have to look at the degree value. Now remember, degree value is the exponent, the highest exponent in the numerator or the highest exponent in the denominator. You're going to compare those two. If the numerator of the top is smaller, if the degree of the top is smaller than the degree of the bottom, then the horizontal asymptote will be y equals 0.
Could you please come to the main office? Thank you.
If the two degrees are equal, then you have to do a little bit more work to find the horizontal asymptote. And what I mean by that is, if the degree of the top and a degree of the bottom are both the same, then you look at the leading coefficient in the numerator and the leading coefficient in the denominator. You make those two a fraction, leading coefficient over leading coefficient, and you come up with your answer. Whatever, and that can vary. We'll see some examples again on that in a few slides. If you come into a case where the degree of the top is bigger than the degree on the bottom, then there is no horizontal asymptote. So those are your three cases. So vertical asymptotes are at your zeros. Horizontal asymptotes, it depends on your different degrees. We'll go over a few different types of examples. All right, so find the vertical and the horizontal asymptotes. Well, if we're going to find the vertical asymptotes, vertical asymptotes appear at the zeros of the denominator. So we focus just on the bottom, and we set the bottom equal to 0. Now, if you did the math out, you would end up with 3x squared equals negative 1. You could divide by 3. Here, negative 1/3. You try to take the square root. Can you take the square root of a negative number? No. You're going to say there's no solution here. How can we interpret this? Well, if there's no zeros to the denominator, well, that means there are no vertical asymptotes. No vertical asymptotes in this problem. There is, however, a horizontal asymptote. Horizontal asymptote. The way we're going to find this horizontal asymptote is by comparing the degrees. The degree of the top is 1. The degree of the bottom is 2. Anytime the degree on the bottom is the bigger number, so 2 is the bigger number when you compare 2 and 1, the horizontal asymptote is always y equals 0. Every single time, absolute guarantee. All right, so this was kind of an entry-level question. Let's see if we can find one that's a little trickier, maybe a little tougher. All right, let's look for vertical asymptotes first. Find the vertical asymptotes the same exact way we did it on the last slide. What I mean by that, we take the denominator, set it equal to 0. X squared minus 1, set it equal to 0. We can solve this one. In fact, you should get 2 solutions. If you are thinking of adding 1 and taking the square root, I caution you, make sure you include a plus or minus sign. I prefer to write this as a difference of 2 squares, because now I can actually see, all right, here I'm getting x equals negative 1, here I'm getting x equals 1. Those are my 2 vertical asymptotes. X equals negative 1 is a vertical line, so is x equals 1. Those are my 2 vertical asymptotes. My horizontal asymptote, I find my horizontal asymptote by looking at my degrees. Now in this problem, the 2 degrees are exactly equal. If that is the case, I have to examine the leading coefficients. The leading coefficient on the top is 2. The leading coefficient on the bottom is 1. So I take 2 over 1, and my horizontal asymptote is just going to be y equals, now you can write 2 over 1, but it's probably easier to just write y equals 2 as your horizontal asymptote. We'll graph these shortly, but let's first just practice finding the vertical asymptotes and the horizontal asymptotes. So hopefully we're starting to see a pattern, vertical asymptotes. When you're finding vertical asymptotes, it's a fancy way of me asking you to find the zeros. So x squared minus x minus 6, set it equal to 0. You're staring at a trinomial. I hope you've been conditioned in Algebra 2. If you're looking at a trinomial, you want to try to factor it first. If that's not working, you try the quadratic formula. But here, this is factorable. X minus 3, x plus 2 equals 0. So our 2 vertical asymptotes, x equals 3, x equals negative 2. That's half of our answer. To find our horizontal asymptote, well, I examine my degrees. Both degrees are 2. I hope you're saying, look at the leading coefficients. Here are our leading coefficients, and we're going to say y equals 1 over 1 or y equals 1. They both work. Moving right along. Here we're going to state the domain. We're going to find the domain, state the vertical and horizontal asymptotes. Finding the domain is very similar to finding the vertical asymptotes, so it's almost the same question. The way you find the domain is you figure out what makes it undefined. Well, you're going to have to look at the bottom, set it equal to 0, and you're going to need to solve this. Well, minus 5, cross out. Negative 4x cubed equals negative 5, divide by negative 4. You have x cubed equals 5 fourths, and you would need to take a cube root here to get x by itself. So you would have x equals the cube root of 5 fourths. That's our first vertical asymptote. In terms of the domain, all real numbers except
Shanice Acevedo,
cube root
your
of
transportation
5
is waiting
fourths.
outside. Shanice Acevedo,
5 fourths,
your
that is.
transportation is waiting outside. Thank you.
Now, notice I do not need a plus or minus there because the cube root, you don't need plus or minus. If it was square root, I would need a plus or minus. Well, your horizontal asymptote, so here's your vertical asymptote, right here. Here's your domain right here. And your vertical your horizontal asymptote, again, you examine the degree. They're both the same, so you're going to pick the 2 numbers associated, the leading coefficients is what they're called, 3 and negative 4, y equals negative 3 fourths. Going to be your horizontal asymptote. So all this information can be obtained just by looking at a graph. This is a little bit of a challenge problem, and this function actually has 2 horizontal asymptotes. The absolute value makes it have 2 horizontal asymptotes. So why don't you try to figure out and come to class prepared to answer, what do you think the 2 horizontal asymptotes would be to this graph? I think there's one that's relatively obvious. The second one might be a little trickier. So give this your best shot, see what you come up with, and when I see you in class tomorrow, we'll go over this problem.